Okay, I've had a couple of people ask me about the batteries I use when I'm operating portable. Now, long story short, I use lithium because they're lighter, easier to carry. This is the battery you've seen me use when I've been out doing summits on the air. That's what I power my Icon 705 with. You can buy these. I homebrew them out of 18650 batteries, which are recycled from older laptop batteries, and I'll probably do several parts on this video, turn it into a mini series, but that's basically what's inside it. Obviously more than one of them. There's about 15 I think in that one. So that's portable. If I'm operating say from the caravan or somewhere like that, or I need a bit more power, I'll generally use this. This is basically the same as the other one, but it's just got more cells in parallel. So I think that other battery, if you believe the manufacturer's specs, it's about 9 ampere hours. I think I actually measured it at about 7 or 8 ampere hours. This is 50 ampere hours according to the battery specs. It'll be a little bit less than that because you can never draw 100% out. But that is, believe it or not, roughly equivalent to this great thing. This is a 110 ampere hour leisure battery. Hang on, let me just put this down. Picking that up for demonstration wasn't a good idea. So that's a 110 ampere hour leisure battery. That actually came out of the caravan. I've got another one which I use for radio, but I only really use them if I'm operating from the car or from the caravan because they're just, as you saw, just so heavy. But despite that being a 110 ampere hour battery and this one being about 50 ampere hour, they're actually, believe it or not, roughly equivalent in capacity. And there's a reason for that. I'll show you why in a minute. But which would you rather carry? Would you rather carry this or that huge great thing? I know which one I'd rather have. And this, occasionally I'll take it on the SOTA with me if I want to run a 100-watt rig, but generally I don't bother. I just run QRP when I'm out on the SOTA with this thing, much easier. So I said those two batteries are equivalent despite the 50 ampere hour having less than half the capacity of the lead acid. And let me show you why on this computer screen here. And if I put my screen capture on, you can actually see what I'm looking at. So this is the state of charge or discharge for leisure batteries. So this is lead acid batteries. So you can see how the voltage declines as you use up the capacity of the battery. Now, different people will tell you different things. Some people say you can go down to 50% state of discharge safely. Some people will tell you 75%. Depends who you talk to. This chart, basically you should be keeping your battery in the green. So this chart says you can go down to 60% state of charge. So you can basically use 40% of your battery capacity. If you go down into the orange here or the red, then you're going to risk damaging your battery. And if you do it too often, then basically your battery will stop holding a charge and you'll knacker your battery. So, I mean, look, like I say, some people say you can go down to 50%, some people say 75%. Let's go on what this says, which is 60%. So you can use 40% of your battery before you need to recharge it. So get a calculator, and I'm terrible at maths. I actually failed all my maths exams in school, but here we go. So let's take that. The example of that lead acid battery is 110 ampere hours, and we can use 40% of it. So multiply that by 0.4. So 110 times 0.4 gives you 44. So although it's 110 ampere hour battery, we've only actually got 44 ampere hours usable capacity in there before we get to a point where we're risking damaging our battery and we have to recharge it. So that is a lead acid battery. Now if I go on to the next slide, this is the discharge of a lithium ion battery, which is which is what these 18650s are. They're lithium ion. Okay, so fully charged, I don't charge them up all the way. They recommend charging to about 4.2 volts. This chart shows nearer 4.3, 4.4 volts. I typically wouldn't take them up that high when I charge them, and you'll get an initial slight drop in voltage, but then notice here, by the time you get down to about 85% or so, 90%, you hang at 3.75 volts all the way down to around about 20-30%, and then you get this sudden drop. So you can take a lithium ion battery down to around about 20% capacity here before you seriously risk damage to the battery. So let's do the same calculation again that we did for the lead acid, but let's do it with this. So we can take it down to 20% state of charge, so we can use 80% of that battery. So let's take the example of my big battery there, which was I said was 50 ampere hours. So 50 times and we can use 80% of it, so 0.8, and on my calculator I've got 40 ampere hour battery, or 40 ampere hours of usable capacity in that battery. So basically 110 ampere hour lead acid battery I can use 44 ampere hours out of, or 80% of a lithium battery, which if it's a 50 ampere hour battery takes me down to about 40 ampere hours. And I've actually capacity checked that battery on I've got a charger for it, and you can capacity check on it, and that is actually pretty much spot on. That is basically what I can draw out of it. So if I go on to the next one, the other thing to note is, as I touched on before, this is the discharge. So as I said, lithium ion, you get that initial drop and then it stays fairly constant. Now these are higher voltage batteries, like you'd see in electric scooters, or you know, that sort of thing, electric bikes, etc, etc. So it's higher voltage than what we'd use, but it's fundamentally the same principle. So lithium ion here, you see you get that initial drop in voltage and it stays pretty constant across the discharge curve, about half a volt drop they reckon here, and then you get this sudden plummet here once you get to about 80% or so. Lead acid, see you get this constant decline, and over the depth of discharge here you're getting 6 volts drop, if not more, on the bigger battery. Like I say, we're dealing with 12 volts, so it wouldn't be quite so much. So there you go. Long story short, that's why I use lithium batteries. You can get pretty much the same amount of charge, and I'd say this little battery that I've built is probably the equivalent of maybe about a 12 ampere hour lead acid battery. In fact, you might even get more out of this than you would a lead acid battery. I've not done the maths on it, but I'd consider them to be roughly equivalent. So that is why I would rather use lithium batteries than lead acid, because they're lighter, they basically do the same job, and easier to carry, and smaller as well, much smaller. So there you go, that's the first episode. Next episode, I've got one down here, which by the way, if you're wondering what that looks like inside, it's basically made up of, you get these little battery holders and a load of 18650 batteries inside. That's fundamentally what that battery looks like inside, with a few extra bits thrown on for safety more than anything. And I'm actually going to build this up into working usable battery packs. I'm going to film that, so that'll be the next 2 or 3 videos. I'll make this into a little series on building lithium batteries.